Okay, we're going to look at the reactivity series, and we're going to relate the position of metal within the reactivity series to the idea of displacement reactions, which is something we covered in halogens. But let's relate it to metals. I want to choose some metals. I've got sodium, I've got magnesium, I've got iron, and I've got copper. And I've written them in that order because as you go down that list, we've got decreasing reactivity, which means sodium is very reactive, then magnesium, then iron, and copper is least reactive. Now, the way that works is if I have sodium and I react it with copper chloride, then we end up producing sodium chloride and copper, which is fine. But what about if I have iron and I react it with magnesium chloride? Does that get a reaction? And in fact, it gives no reaction. We need to explain why. Let's go to the reaction which works. If we look at sodium, this is the first example here, it's reacting with copper chloride, and there's a bond there between the copper and the chlorine. Sodium is up here. It's more reactive than copper down here. Because it's more reactive, it wants to form a bond with the chlorine, and this bond here gets scrubbed. So we end up producing sodium chloride, and we leave out, we displace, hence the word, the copper. What happens with the iron example? Well, here, iron here is not more reactive than magnesium. See, it's lower here than it is the magnesium. So iron is trying to push out the magnesium. Iron is trying to push out the magnesium to bond to the chlorine, but it's not able to. It's not reactive enough, and that's why we get no reaction there. At writing simple equations for that now. So let's go back to the sodium example. Sodium is Na. Copper chloride is CuCl2. Now, if you're not sure about that, copper, remember, from your valency table is +2. Chlorine from your valency table is -1. Ignore the signs. We've ignored the plus, we've ignored the minus. We swap them over. So the 1 goes across to the copper, the 2 goes across to the chlorine. We drop them down, and then we simplify. So that is the formula of copper chloride. We can't change that. And we produce sodium chloride, which is NaCl, and we produce copper. Again, if you're not sure about the formula for NaCl, Na is +1, Cl is -1. We do the same, ignore the signs, swap them over, it's exactly the same, drop them down, and then simplify is just NaCl, and we're not allowed to change that formula. Let's just do some balancing now. Sodium over here has got 1 sodium, 1 copper, 2 chlorines. Now, you might be tempted to put a 2 after the Cl, but we can't, because we can't change the formula. That's the formula for sodium chloride. So all we can do is say 2 sodium chlorides, which now means that we need to start off with 2 sodiums, and that's it, finished. You might also want to put some state symbols on. Sodium's a solid. Usually the copper chloride is aqueous. The sodium chloride here is aqueous, and the copper is a solid.